Yeah, hello. Welcome to Galaxy's Academy. So today we'll be talking about the most simplest topic in physics. Is one which almost all science students will be able to explain in details. But that's none of my business. Today we're starting with the basics, right? So today we'll be talking about scalars and vector. Scalars and vector quantity and vector quantity. If you would like to engage with this video, kindly pause it and define in the comment section what scalar mean and what vectors mean. Alright, let's dive in. Okay, the first thing we're talking about today is the scalar quantity. Right? What's scalar quantity? What do we understand by scalar quantity? Okay, so scalar quantities are first physical quantities. You have to note that scalar quantities are physical quantities, right? So, and also, there are physical quantities that have magnitude. I'll explain to you very soon what magnitude, what they mean by this magnitude. So, magnitude and direction. Sorry, magnitude and no direction. I take that back. Magnitude and no direction. Is that fine? So, actually, everything or everything, yeah, everything in the world is represented by something, right? Either by a figure, either by an image, or whatsoever. For instance, when I see the clothes you put on, I can be able to guess where you're from. Or if I see how you speak, I should be able to have a clue that oh, this particular person is from this state, this particular person is from this state. Also, in likewise manner, scalars can also be represented by certain things that can serve as clues. Now, they are represented by a single number or value, usually accompanied by appropriate units. So we can have something like, let's say, 5 cm, 30 kg. Can you see? 30 kg. What else? And so on and so forth. Let me not go too far. And so on and so forth. So whenever you see something like that, you'll be like, since they didn't specify direction, this should be scalar. Do you get? This should be scalar. Alright, moving on to the next. Vector quantities. So what do we understand by vector quantities? In likewise manner, pause video and try to explain what vector quantities is in the comment section below. Vector quantities are physical quantities that have both magnitude and direction. So vector quantities have magnitude and direction. As simple as that. So there are several examples. We'll be coming to that shortly. Vector quantities are represented using arrows, right? I said earlier that scalars are represented using just numbers, numbers and units, values and units. But now vectors uses what arrows. Why? There's a reason why they are used to lay more emphasis on direction, right? To give detailed um, description of that quantity. Do you get? So we can have something like this as the arrow, right? This is pointing, this is north, sorry, this is west, east, north, south. So this part is pointing in the east direction. The length, this length here specifies what? The magnitude. While the pointer, this particular end, right, specifies the direction. Do you get that? It specifies the direction. Please do not forget that. Also, vectors can be written in their components along the coordinate axis, typically represented as x, y, z in dimensional process. So you will notice most like in you will notice in vector quantities generally that we can represent it as, let's say, 2i plus 3j plus 6k. This means x direction, this means y direction, right? That y axis or x axis, anyway, and put it as. So k represents what? Z direction. In subsequent video, I will explain to you how we can solve with this. Now, I forgot to tell you something very important under scalar. You should Scalars can be added, right? So when we have two scalars, how can we go about it? How can we go about the calculation? Now it's just like your normal arithmetic calculation. So you can subtract scalars, you can add scalars, you can multiply scalars. So when I have 2 kg times 2 kg, it should work, or 2 kg plus 2 kg, it should work. Do you get that? But I can't add something like 2 kg plus 3 centimeter. They are not the same unit. It won't work. Exactly. Alright, now what of vectors? How can they be added? Vector addition involves combining the magnitudes and direction of two or more vectors using parallelogram law or triangular law. So we can have to calculate vector or to add vector, we have to use parallelogram law and addition law. Sorry, triangular law. Or triangle law, triangle rule or triangle law. So whatever I take it out, you get. So that's that for that. So now let's get to know some examples of scalar. Let's know some examples of scalar. Right? So how can we identify scalars and so the most all you should know that all fundamental quantities, like we have 7 fundamental quantities, isn't that true? So all fundamental quantities are scalars, right? All fundamental quantities are scalar. Also, all quantities or most quantities, let's say most quantities that ends with a n c e are also scalar. Do you get? All right, let's go to the number one. So some fundamental quantities that you should know are mass, right? We have mass, we have temperature, right? We have temperature, right? Also, time is also a scalar quantity, and speed too. Okay, so when I talk about mass, how will I know, or what's the proof that it's a scalar quantity? Whenever I'm talking about mass of something, I don't need to verify, or I don't need to specify that, oh, it's facing north, it's facing south, it's facing east. No, I can just say I bought 1 kg of sunlight for 3,000 naira. Not that I bought 1 kg of sunlight facing the west direction for 3,000 naira. No, the direction is not necessary. Also, temperature 30 degrees Celsius and all that. You get, those are some of the examples of scalar quantities. There are many more, many more. Let's talk about them. Even I don't discuss them in details. Let's just talk about them a bit. Okay, so we have all energy, anything that has to do with energy as scalar quantity. So we have kinetic energy, we have potential energy. All these are actually what? Scalar quantity, right? Are actually what? Scalar quantity. Resistivity, resistance, capacitance. Just going back to this again, right? So capacitance capacitance, resistance, look at this, can you see it, are all what? Scalar quantities, are all scalar quantities. Now let's move to vector quantities really quick. All right, so some examples of vector quantities. Kindly pause the video and write in the comment section some of the vector quantities that you know. All right, let's move on. So some of the popular vector quantities that you should know are displacement, right? Velocity, right? Remember, in scale, speed is a scalar quantity. Do not forget. So also force. Force is also a vector quantity. So let's talk about this. Let's talk about um, displacement. Now, if you move from point A to point B, your displacement is a vector quantity, right? So from this part, this is A, to this part, B, your displacement is a what? Vector quantity. That is, it has both magnitude, that is this distance traveled, and the direction from A to B. First, from this my example, I'm moving in what? The north direction. I'm moving towards what? The south, I mean to say. I'm moving towards what? The south. If I'm moving this side. To get where I'm moving up, I'm moving what? Towards the north direction. Right? Okay, so velocity also is a scalar, is a vector quantity. Force is a vector quantity. So what are other examples of vector quantities you have to take note of? They are much. Weight is a vector quantity, right? Electric flux is a vector quantity. Angular momentum, vector quantity. Net torque, vector quantity. Momentum, vector quantity, right? Electric field strength or electric field intensity are all vector quantities. Let's treat some questions. Really quick. All right, so the first question says, which of the following is a scalar quantity? By now you should know the answer without me saying it. Can you try? All right, so for the first one, is the first one a scalar quantity? Nope. The first one is not a scalar quantity. This is not a scalar quantity at all, right? Instead, speed is a scalar quantity. All right, what about acceleration? Nah. I said so. It's not a vector. It's not a scalar quantity. How do I know? Because learning or memorizing every single one of them will be much for you. Don't you think so? All right. So let's look at the formula, which is what? Velocity over time. So whenever we have a, most times, not always though, but it's a clip. So whenever we have vector quantity in the formula, most times the quantity in particular is a vector quantity, right? If it has a vector quantity in its formula, just like this is a vector quantity. Definitely acceleration will also be a vector quantity. What of temperature? Is temperature among the fundamental quantities? Yes, it is. It is among the fundamental quantity. So let's keep this aside. Fundamental quantity. What of force is also a vector quantity. So this is the only scapegoat here. So temperature is the correct answer. Which of the following is a scalar quantity? Temperature is the correct answer. Why? Because temperature is a fundamental quantity, and I've said before that all fundamental quantities are scalar quantities. Alright, so what's the next question? Which of the following is true about mass and weight? First, let's make some things clear. Mass, scalar. Weight, vector. Mass is a vector quantity. Is this true? Nope. Weight is a scalar quantity. So number one is out of it. Mass is a scalar quantity and weight is a vector quantity. This look a little bit true. Let's mark it. Both mass and weight are scalar quantity. How come? Never possible. Nope. More than one more than one of the above is correct. I wanted to write that. So this is wrong and this is wrong. So option 3 is the correct answer. Alright. Option 2 is what? Is the correct answer. Right. So let me discuss a little bit about mass and weight because it will definitely help. Right. So you should note that mass is a fundamental measure of the amount of matter in an object. So when we're talking about a box here, right, we're talking about I don't mind my drawing. So when we're talking about there are matter here, right? So the total amount of matter in a body refers what to the mass, refers to the mass. But when we talk about the weight, it's actually the force of gravity acting on this box. It's actually the force of gravity acting on this box. That is G, acting on the box that results to weight. Do you get? So that's why weight has a formula. The formula for weight is W equals to what? mg. So this determines the weight. If this determines the weight, that means weight cannot be constant. It will vary according to the planet we are on or the body we are on. Right? Okay, so mass is always constant, but weight varies. Also, mass can be measured in kilogram or grams, but weight is always measured in Newton, right? Mass can never, never, never be zero, but weight can be zero. Yeah, it can be zero, right? So just like in elevator, which I'll teach very soon, you can have weightlessness. You can experience weightlessness there, right? All right. So the last question. They asked which of the following is not a vector quantity. Please pause this and answer it, and you must not fail it. You shouldn't fail this. All right. So for the first one, weight, is weight a vector quantity? Yes, I just said so. Okay. Nuclear spin, is it a vector quantity? You might not know this, so let me keep this aside. You might not understand what I mean by nuclear spin. I'll come back to that. Is momentum a vector quantity? Yes. What I tell you about energy, whenever I see energy, they are always what? A scalar quantity. Don't stress yourself. Don't stress yourself. It's always a scalar quantity. So what I mean by nuclear spin, you might have heard um, Hund's rule, right? You might have learned about Hund's rule in chemistry, or if you have not learned, don't worry, Gallant will take care of that. Do you get? Okay, so we have something like this, right? These are orbitals. This represents 1s, 2s, 2p. Do you get? These are electron. These are electron. So let's assume something like this. When we're talking about the nuclear spin, we're talking about how these electrons here orient themselves. You can see how they orient themselves in a definite way. One is pointing up and one is pointing down. You get? So that's what the nuclear spin talks about. So from here, we know that nuclear spin has a direction. So they said which of the following is not a vector quantity? That is, which is a scalar quantity? The correct answer will be what? 4, which is potential energy. I hope you learned something today. I really wish you learned. And if you're new here, consider subscribing to this channel. Right? Subscribing to the channel. And above that, we have a premium class ongoing. We have premium classes ongoing, and if you would like to partake in it, feel free to drop your number in the comment section. I will reach out to you. But if you don't want to drop your contact, don't worry, in the description below there will be a link that will direct you to us, right? And I promise you won't regret it. There are a lot of things you will learn from us. Thank you for watching. See you next time. Bye.